All right, well, welcome again, everybody. So we're just going to, we're going to be talking about DNP3 today. So first to begin here, what is DNP3? Well, DNP3 is a communication protocol for SCADA systems that was developed by Westronic in 1993. And Westronic took the unusual move at the time of developing an open protocol. So they didn't keep this quiet in-house and secret so that only they could talk to their devices. They published how they were communicating. And because of that, this has been adopted by a lot of device manufacturers and is supported by SCADA systems, including VTScada. And at the time, the IEC 61850 protocol was also being worked on. And so there were some elements of that protocol that were brought into DNP3, and then of course some DNP3 special stuff. And when Westronic completed the protocol, they passed it off to a public users group, the DNP3 users group, which has been maintaining it ever since. And so you can get spec documents from them, and they release new versions and things periodically. And later, the UK WITS protocol was developed, and it's got some elements and basis in DNP3 as sort of an extension to the public DNP3 protocol. And VTScada actually supports a couple of WITS features with more on the way.
In your experience, what percentage of applications for the monitoring control industry use DNP3 versus, say, Modbus or something else?
I might be a little skewed myself, but DNP3 is a common protocol. So we see a lot of Modbus, we see a lot of Allen Bradley based like SIP, DF1 type things, and DNP3 might be the third most common we see, or something in that territory.
Gotcha.
And it really does depend on your application. It's more suitable for certain types of systems than others. Westronic's an electric utility supply company. So the protocol was initially developed for the electrical industry, and it's very widespread in those applications, but it's also been widely adopted by water and wastewater applications, and it is bleeding into other industries as well. So it's got fairly wide use, but certainly the electric and water industries are the most common. And it's really well suited for remote telemetry situations. So if you have 100 lift stations buried across your city, DNP3 is going to be a very good protocol to use to talk to all of them. And so leading in here, why do we use it? Well, we start a lot with protocols with Modbus. Modbus is sort of the genesis protocol. Very simple command response, give me the value of this IO address right now, and here's the response. And that works well for certain environments, but there are a variety of places where it doesn't work that well. For one, Modbus was limited to 16-bit registers, and a lot of people over the years have done a variety of unpleasant things to get different kinds of data types into Modbus. And DNP3 just has native support for a whole lot of other things: floats, counters, strings, files, and other functionality. So it's a lot more modern in that way, and you don't need to worry about quantization effects and things like that really at the level you'll be using the protocol. DNP3 also has really high tolerance to poor communication channel quality, and this is because of its origins in electric systems. Really high electromagnetic interference environments can wreak havoc on communications. So DNP3 has a ton of built-in error checking. Every 16 bytes, I believe, have a CRC on them. So there's a ton of checking all across the message packets in DNP3, so that when you get the message and everything passes when you inspect it, you can be very, very confident that you have the correct message. So it's really good when you have marginal communications. And in that vein, a lot of the larger messages are actually broken up into smaller fragments for easier transmission. Another real strength of DNP3 is that we have timestamp data coming in for the data points we're actually measuring. So with Modbus, you poll it and you get the value at the time that you reach the device. And if you're not polling it for a few minutes, you don't have any values in that time. With DNP3, everything is timestamped when it comes in, and there's the ability to read many different pieces of data at once through a larger historical time period. So with the timestamped data, you don't have to you don't have to actually pull the device as often, but you can still get very high data resolution, and it can be backfilled into your history as it was seen by the device. And this kind of leads into the polling schemes that we see with DNP3. So we have event-based polling and report by exception schemes that we're going to talk about next. That was an interesting order there.
Thanks.
Yeah.
PowerPoint.
A lot of these things with the poll by exception, report by exception are especially useful on radio networks, cellular networks, dial-up networks, or satellite-based communications. But really anything where it takes a lot to actually reach the device that you're communicating with, or where you might have bandwidth restrictions that mean you don't want to be communicating back and forth constantly or with large sets of data. And so depending on how you configure things, and some of this you'll be doing inside VTScada, but some will actually be dependent on the device manufacturer, you can get really good high data resolution with infrequent communications without using a whole lot of bandwidth.
And what does the asterisk mean?
Well, it just means that we aren't always in control from
Right.
VTScada side. So usually you'll configure bandwidth settings for a particular piece of I/O that determines how often it might report in or how often it might collect events or something to that effect. If you configure that to be, very frequent, you won't have low bandwidth because the device will always be sending you data every time something changes. All right, so we are going to look at the variety of DNP3 polling methods that are here that sort of lead to the strengths of the protocol. So back to Modbus, direct polls. We send a request, read to get the data for one tag or one data point from the RTU. Now DNP3 still supports this, but if you're going to use it for that, you're going to miss out on most of the benefits of DNP3. So we typically don't recommend that people use this, although the driver in VTScada does support it. The next type of poll we have is an integrity poll, also called a class 0 poll. And this is a single message that we send to the device that basically says, send me all the data you have. So it sends all the current values for all the tags in the RTU. It's somewhat like the direct poll, except instead of asking for each individual thing, we just send one quick message that says, give me everything you've got. And typically what you'll do is this will be sent immediately when the DNP3 driver starts up, so we know what all the values are at that point. After that, we will send periodic event polls. And an event poll allows the RTU to decide and tell you which tags have changed and to give you the new data for those tags. And this is where the strength of DNP3 starts to come in, because we start with the integrity poll, we read everything that's there, and then we send out an event poll and we read just the things that have changed. So we may have 100 I/O at the site. When we send down the event poll, maybe only 2 of them have changed. So we just get new data for those 2 tags. We don't need the device to send back data for all 100 tags because they haven't changed, and we already have that information from the integrity poll we did. We don't need to get it again. And finally, we can have unsolicited data. And so in this case, VTScada is not sending down a request for the data. The RTU is deciding when to send the data to the master. And so this can be more bandwidth efficient generally because we don't need to send a message down to say, give me all your changes, to only to discover that there aren't any changes for it to send us. So we're just going to dive in a little bit on these.
Great.
With a little bit of a demo that sort of demonstrates what we're looking at here. So we've just made a quick sort of simulator in VTScada here so you can see what's going on. So what we've got on the left-hand side is we have an RTU level. So this is just a graphic that shows what an RTU might be seeing locally on site. So you've got a level that's filling and it reaches a certain value and then it starts to go down. Perhaps there's pumps in the well, what have you. And what we've got here is we've got a direct pull method of communication. So every 10 seconds, we're going to pull it from the SCADA side. And so each 10 seconds, you'll see this arrow pops up, we pull it, we get the value at that point. And so we're sampling the data as it comes in. And you can see a trend starting to develop. And so one of the things that you'll notice about this, of course, is that the level is moving much more, but we are only sampling it so often. And we're sampling it based on time, and a Modbus protocol or DNP3 with direct pulls really can only do that by time, which may not be most useful. And the other thing that happens is if the level stops moving, or if you're monitoring something like a reservoir level or a lake river level, something like that, that may not change very often. A significant change may only occur every hour or once an hour or a couple times a day, who knows. You're going to be polling still every 10 seconds just to discover that it hasn't changed. It's still 33.4 feet. And if it costs you something to actually perform that communication, you're paying for that every time, and you're not getting any more useful data from it. By contrast, when it's changing a lot here, this is actually changing very frequently, but we're only pulling it every 10 seconds, so that's the data resolution that we get. So if we look at a DNP3 based scheme with pull for exception, rather than having the SCADA just get the data when it happens, we instead have events that are being generated. So the RTU has a deadband set for this of 1. So every time the level changes by at least 1 foot, we will log an event, and we'll log, in this case, it's logging up to 10 events. But that is, again, usually an RTU level thing. VTScada won't have any control over that. We'll just read what's in the event buffer. But you can see down at the bottom left here, we're getting those events and they're being stored with the timestamp and the value at that time. And then periodically we have a poll come from the SCADA system and it retrieves, it clears that event buffer. And DNP3 has a lot of safety mechanisms in it. So we do the read and it sends the events, and then we send back a confirmation message, and that's when the RTU knows to clear those events. So if you have interruptions in the middle of this sequence, most RTUs, if they're compliant with the protocol, will continue to hold the events locally as long as they can. And again, that will depend on the RTU because it will have a limited amount of memory. Right. It'll be able to hold a limited number of events, and it's really up to the RTU manufacturer to determine what's reasonable. And then the other thing I'd point out is because we're logging this and still only communicating every 10 seconds, but because we're taking an event every 1 foot change, you can see our curve has really smoothed out here. We've got really high resolution data, and it's flatlining a bit while we're waiting for our poll, but then it backfills it. So we have full history, nice and continuous. And this can also be very, very useful. Again, DNP3 shines here when you have an unreliable communications channel, because if this just drops, our RTU stops talking to us for the next 20 minutes, well, the event buffer will fill up, there'll be lots of stuff there, and then we next poll for the events, poll for exception, we'll get a full backfill of it, and it'll come into VTScada. Our final scheme here, we have report by exception. And the only difference here is the SCADA is not deciding to poll every 10 seconds. The RTU is deciding to send everything in every 10, 5, whatever you configure, events that are actually in the log. And so we accumulate them at the RTU and we send them into the SCADA system. And so there's a variety of schemes that people use with this in DNP3. Generally speaking, either individual I/O on the RTU will be able to have their dead bands or their event buffers or anything configured. Or sometimes the data is broken into classes, and we'll see that somewhat later, but it's mostly an organization thing. And again, this is an RTU side construct. But what happens here is you might configure the level of your lift station. Yeah, it's changing all the time. You don't critically need that. Maybe once you've got 10 pieces of data for it, or you've had events in there for at least 2 minutes, or whatever metrics you want to use, you should just update the SCADA system so it's relatively up to date. But you might decide that a alarm, maybe a high-level alarm or a pump failure alarm or whatever else you've got that's very critically important, maybe you should send that alarm right away. And so for that particular piece of data, any event would immediately trigger it to say, send this in. And with DNP3, what will typically happen is it will send in everything it's got at the time. So if it gets the alarm and maybe it's also recording a level, but it's not reached a point where it needs to send that in, it would usually include everything in that message coming in. And it might as well, because you are going to collect all the data eventually. So anytime you reach the device, it might as well just clear off what it's got at that point.
That's great. I like this demo app. Did you create this with the Idea Studio?
Yeah, so everything here is created in the Idea Studio. In fact, these top controls are all also built-in generic VTScada things. So yeah, these are all leading to system settings, and that's leading to an analog output type of IO tag.
That's great.
Yeah.
Are we able to supply this to people, or would it be meaningful to them?
We might.
Okay.
If anyone's interested, you can certainly use it and play around with it. Things mostly work. So this is our polling schemes. And DNP3 is typically, as we described, going to implement a variety of them. So we're going to move into a VTScada application here and do a little bit more with DNP3.
So you're creating a new application from scratch.
Yeah, this is a new empty application, no special hidden secret sauce in here. Just gonna
nothing up the sleeve.
Not quite. But just gonna bring this up empty and just show you how to put a very simple communication chain together for DNP3.
These are all our past webinars, by the way.
Yes, if you see any topics down here that are interesting in the background.
So these are all the things you see every time you create a brand new application. The historian's already set up.
Yeah, lots of stuff is in these by default, but from our perspective, IO tags and drivers and things like that, it's a full blank slate. And so what we're going to do, we're going to add a new tag here, and it's a driver. So it's in the driver section along with all the other device libraries that we've got. We are going to select the DNP3 compatible RTU. Give it some name. Doesn't really matter.
And this protocol is available out of the box at no extra cost.
That is correct. So just hopping through the configuration here, we're going to configure a port. So the port is the communication channel that you're going to use to reach the device. Now, the DNP3 driver supports all of the port types in VTScada. So that's serial ports, which you use to communicate something, connected to a COM port on your computer, or dialed out through a modem. TCP ports, which are IP-based communications, and UDP ports, which are also IP-based communications using UDP. So we're going to pick a UDP port here. You can use this with any type. You can use any type of port with VTScada's DNP3 driver, and this is a reasonably good option. And so we're just going to make one of these, throw in an IP address. And DNP3 typically communicates on port 20,000. Most devices will let you pick that, but this is the registered official port for DNP3. And so we're going to choose that port tag. Now our driver is pointing at that port tag. That's what it will use for its communication scheme. There's a couple things you'll probably want to set up for your particular DNP3 device. So over here in the data link section, the timeout, that's how long we'll wait for a response before we give up or maybe retry. And that should really relate to the communication channel you're using. So if you are going to communicate over cellular, for example, half a second may not actually be enough time for the cell modem to wake up and respond to you. So you might need that to be a little bit longer. If you have a device sitting on your local network, Half a second is a ton of time for something to respond under those circumstances. And we also have a backout mechanism. So if we try to establish communication with the device and we don't get a response, we fail to do that initial integrity poll and the whole initialization sequence, you can configure this message fail time allows it to wait a longer time period before it will try again. So if you have a shared communication medium, which is pretty common with DNP3, you might want to have this relatively large. So one bad site trying and failing over and over again to establish communications doesn't prevent all of the other sites from getting their turn and getting their chance to talk. And down here, the retries relates to the timeout limit at the top. How many times after we do timeout will we resend the message we were trying to send and try for a response again before we declare failure and move on? These are reasonable for our purposes right here. On the data link tab, we have the master address and the station address. So every node, every DNP3 node in a network is going to have an address, and it just uniquely identifies which thing you are. And sometimes with IP-based communication, it's not that important. And some devices may not even really care what you set. But especially if you had, say, a radio system where you had 20 DNP3 RTUs that you were polling, you're just broadcasting out. They can all see the message, and it's based on the actual station address that you're sending it to that particular station would pick up the message and respond to it. This data link confirm option might be a good thing in a radio system. That provides, at the cost of a little more bandwidth, a little bit more error checking and confirmation at each time we send a message or receive a message that we actually got it. So this can be useful to turn it on if you're in a questionable communications environment. And finally, here on the options tab, is some control over the actual poll sequence that the device is going to use. So we saw the various types of communication here. And what it will do is it will immediately do an integrity poll. And then after that, it will do these check RTU events. That's the event polling. It sends down a message to say, do you have anything for me? And so here, as configured, it will do that every 10 seconds. And then over under the poll options, you can actually control which of the 3 data classes it's going to do that for. Now, as we mentioned earlier, you're ultimately going to get everything. There's no cost in asking for it each time. So typically you will leave all of those enabled and not check these boxes. But you are able to control and turn that off if you wish from here. Next, again, if your events are going back and forth and everything is good, you're going to have up-to-date information at all points. But for peace of mind, people will sometimes do an integrity poll every, in this case, 10 minutes, but every so often just to make absolutely sure that they don't fall really far out of sync. Of course, DNP3 already knows when it's falling out of sync because the events will be backfilled the next time it checks anyway. So this shouldn't be a necessary construct, but some people will use it just for peace of mind, and it might be 10 minutes, it could be an hour, it could be a day, or it might be disabled entirely. And down here, if you want to use unsolicited data, note that the device does need to support it. Not all DNP3 devices support unsolicited, but those that do, you can turn it on and off from here. When we do the initialization sequence, we actually tell the device whether or not it's allowed to do this. And again, you can control which data classes come back. So a note on these classes, they are controlled in the RTU, maybe set by the device manufacturer, and it's typically used as an organizational scheme. So we talked earlier, you might have a class of analogs or a class of like data values, and you might have a class of alarms, maybe you have a class of statistics. But it's really up to the device manufacturer or the PLC programmer to decide what they all mean. And typically, if it's all properly configured at the RTU, there's no good reason to be turning them on and off in VTScada. And the last thing down in the bottom right here, timestamps are in local time. In the very early days of the protocol, you could have your timestamp data in local time. This is a disaster of a bad idea and is only maintained here for backwards compatibility. And the reason, of course, is that local time may or may not follow daylight savings time, depending on your actual server and the device in the field. And when you're bringing in timestamp data and you can't agree on what time is, you're going to get into trouble.
So if you've learned nothing else, then don't check that.
Don't check. Well, if your device requires you to check it,
Right.
update the device.
Gotcha.
Because at least 10 years ago, this was made fully obsolete.
Before you move on there, I just wanted to quickly say, this might be for old users, if you hit F1 at any time, it will actually automatically open context-specific help. So when you go back through this on your own, at any point on any particular tab, you can hit F1 and get a refresher course.
Yes, thank you for that. And we use this all the time ourselves as well.
Barry says we eat our own dog food.
We do, we do. All right, so here we have our driver. It's connected to a port, and we're going to just add a simple analog tag to it to read some level value, and that's going to lead us into the addressing. So in order to address DNP3, you have to specify 3 fields typically, and they're represented as this sequence of numbers. So we got 30/0/0. And the first one is the object. This is the type of data. The second one is the variance. This is the format for that data type. And the final one is the index. Which one are we actually looking at? And if you already know DNP3, you'll probably be comfortable just typing these in, but you don't really need to do that. We have these nice address assists that sort of help you out. So the group, variation, and index are those 3 items. And so you can see here are the data types that we have in VTScada that we can use to communicate DNP3. So we have an analog input. That's what we're reading. That gives us the 30. If we were looking for something else, we would change it and it would tell us. And the variation. Now, we talked about direct polling and the fact that you can direct poll. And so you can check this box and it will direct poll. And at that point, you can choose the variation. What type of data do you want? Is it a float? Is it a integer? Does it include status or time or what have you? And because we don't direct poll, we don't recommend direct polling in VTScada. We don't recommend using this. Note that if you are doing this, the RTU may well care how you've asked for it. If you ask for a float, it may not support that. It may not want to give it to you as a float.
So you have to know that first before you choose this.
Exactly.
It's not giving you a narrowed down view depending on what the device.
No, because we don't have that information from the device. But again, we really don't do direct polling. You'll see when I check that box and uncheck it, we have this NS item here that stands for no scan. When you have no scan there, we will follow the integrity poll event model rather than just constantly spamming it every second or what have you for the particular value at the time. And when we do that, the RTU actually picks the variance it sends. And so that's why here we've just saying all variances. Whatever we get, we'll take it and we will bring that value into VTScada. And the index, which one are we looking for? And here we're looking for number 10 as it happens. And so you have that there. And now down under our driver, in a moment, there we go, we should have a value come in. And so there's our value.
It's important to point out for those new to VTScada, you just created a parent and a child tag. So you could add any number of child tags to that parent. And this is normally how we would set up a communication chain, is that right?
It is, and actually we could have made the driver a child of the port as well.
Right.
Now usually you only have one driver under each port, so it's not as useful. But here, when I made that as a child, it automatically connected it to the parent, to the DNP3 driver above. So every single tag I make down here will automatically try to connect using this driver. Right. Of course, we can point them at other stuff to confuse people, but don't do that.
Keep it simple.
Exactly. Exactly. So, all right. There are 2 special cases that I want to talk about with DNP3. So we sort of mentioned that there's some uses where DNP3 shines well, and radio is actually one of them. When you have this shared communication medium, you've got maybe 20, 100 sites that you're communicating from the same master radio station, and you probably need to take turns on it because most radio systems interfere with each other if you try and talk to more than one device at a time. And because you need to take turns, you can only pull those stations once every 5 minutes, 10 minutes, 15 minutes. It depends on, you know, the latencies in your system and how often you need the data and all of that. So I'm just going to hop back into here. So 2 different flavors of radio that we'll talk about. Serial radio, you're going to have one port and you're going to have many drivers. So you're going to have one serial port tag inside VTScada. You're going to have all of your DNP3 drivers using that port. Maybe as children would be a good way to do that. The station address that we saw when we configured it, that's going to identify the RTU. And then we'll just broadcast everything out, and the individual RTU that wanted to talk to us is going to respond. And note that usually in VTScada, if you were communicating with Modbus or one of the Allen Bradley protocols or something else, you would use a poll driver for that. In the case of the DNP3 driver, that logic is all built in. So when the DNP3 driver uses one port, or when many use one port, they will automatically implement all the queuing necessary to ensure that only one of those drivers will be trying to communicate at a time. Because with radio, you have interference and it just makes a big mess. Now, there are newer radio systems that are IP-based, and they can't work the same way because you can't connect a whole bunch of drivers to one UDP port, for example, because then they'd all have the same IP address, and that's not how they work. And so what we use there is the comlink sequencer tag. And so these are all, everything's a tag in VTScada, but this guy, comlink sequencer tag, and it's just a container, and all of the children underneath it will use the same queue as well. We'll do the one at a time polling schemes that that we need in our radio systems. So that's how you would solve that problem. That's how you configure those systems in VTScada. And in a radio system, integrity poll and poll for exception is recommended. If you use unsolicited, you run the risk of having multiple sites at once, all deciding just randomly, because they will be unrelated entirely, that it's time to send data in. And if they both do it at once, you can have interference. There's tons of radio systems that tell you that they can support, you know, control that sort of thing, and maybe they will. But our general experience is that radio is very important to keep the master in charge, and very important to not have the outstations actually, you know, deciding that it's their time to go and sending stuff in and interfering, because it can really degrade your communication channel and take out other more important data that might be going through it.
By the way, just since some people have asked, yes, we are recording this, and we'll be sending a copy of the recording to everyone who registered.
So the last kind of special tag that goes with the DNP3 driver, and we skipped this when we were looking at our driver tag. So we connected with a UDP port tag. If you do unsolicited with UDP and VTScada, it just comes straight in. If you do unsolicited with TCP, you need to add a listener tag to the system. And that tag is responsible for listening on that port. Usually it's going to be 20,000 for the DNP3 driver. So if you are doing TCP connections and you want to do unsolicited, that is still possible in VTScada. But what you'll need to do is you'll need to add this IP network listener tag. I've got one somewhere. There it is. And you'll configure what you'd like to use. It's sort of pointless to use UDP, so you'll typically be doing TCP here. You specify the port number, and if you want, and this is good practice, you might specify a range.
Is that like a whitelist?
Yeah, so this basically says anything within that network can connect in. So it could be a list of individual IP addresses or a list of subnets in CDIR notation. CIDR, one of those. And so that'll sort of help control what's allowed to come in and
Right.
try and connect into the system. Good security practice. And then inside the DNP3 driver, you will choose which of the listeners you'd like to use. So use that listener. And here again, you can specify, well, this particular one is using, you know, this particular IP address that was also in the range. Sort of pointless to do it in both places. So
Right.
do one of the others is really all that's necessary. And of course, you would still need to have a TCP port tag configured for normal communication. What happens is when the device tries to connect in and send unsolicited data, it'll be passed off to the port tag under the hood, so it'll all continue communicating as normal.
Right.
Yeah.
Okay. At 2:38.
Yeah, so we are a little bit over on time, but the very last thing we just wanted to show, because it sort of ties into DNP3 pretty well, is a built-in MultiSmart station, which is in VTScada. And so this was developed with originally Multitrode, now Xylem, under the Flygt brand. And it's just a built-in pump controller inside VTScada that sort of has this neat auto configuration scheme built into it. And there are a variety of lift stations and various other things that can be built in, and you can make your own objects like this that, you know, this like nice, easy, streamlined configuration. So this particular one supports 6 pumps in one well. You bring it in and it automatically configures up to 1,000 tags, depending on the configuration of the device. And all the graphics are already there for you and ready to go. And it's designed for use in the sites and map interfaces, because typically these are used in lift stations. And one of the great things about us supporting this is you don't have to. When we when we release new versions of VTScada, when new versions of MultiSmart are released, we work together with Xylem and we get it into VTScada itself.
There's actually a number of other devices while you're switching over there that we do a similar thing for. In version 12, which is coming out soon, we'll have very similar support for Grundfos devices as well, and we also do that for MPE and a few others. Oh, here they are.
Yeah, so there's a couple things under stations, and keep an eye. Maybe more new ones will come in the future as well. But here we're going to select the MultiSmart station, and this one's in our offices here.
It's just down the hall.
Just down the hall. And what we do is this is how this particular one works, but this is the kind of thing we like to do for sort of automation. This device spits out an XML file that includes everything that we need to know to create the station. And so in this case, that's all of the tags that are configured in that one from a large list that could be there and what their addresses are. So we don't need to configure them each time. And so we bring that XML file into the system, configure a few things here based on what's present in the site, and choose the port tag. And this, in fact, is what we talked to earlier.
Right.
We pulled the level out of that. And so, you know, this particular device actually also supports Modbus, although DNP3 has a lot of benefits for these applications. It's more common to use it this way.
Right.
And away we go.
Kaboom.
And down here on the sites page, we have our device. And here's the MultiSmart, and it's just connected there. It's got some data, and in a moment we should start to see that level move around a bit. When it reaches the top, it'll start pumping it down, and you can see there's all kinds of stuff that's already been brought in. So you don't need to build your whole page and interface. It's all here for you already.
And you could type in a Latin along, and then it will automatically show up on the map.
Yeah, it's actually nicer to just drop the pin. And now here it is on the map.
So what's great about these Multitrode devices is that they're able to support a very large amount of I/O. They're very sophisticated devices. So the nice thing about this utility is that you don't have to spend a lot of time then configuring all that I/O in VTScada. That import that Paul just did does it all for you.
Yeah, so that's really the goal here. You've got a ton of stuff coming in, but you don't have to build it yourself. We're all lazy at heart, so let's not do that.
Laziness prevents errors.
Absolutely, absolutely. All right.
Well, that's great. So are we on to our questions now?
We are on to our question period.
Would you open up the little yellow arrow, the little orange arrow, and then open up questions? Let's see, we have to drag that open. While you're dragging that open, I've actually had one come into my email. Here we go. So first question, can VTScada convert Ethernet IP, Alan Bradley, to DNP3 internally? Or is it an Ethernet IP to DNP converter required?
I don't know the answer to that question, but it sounds like a no.
Right, so no, very good. So can VTScada convert to Ethernet to DNP? No.
I mean, Ethernet is a transport mechanism. So DNP3 can be, you can communicate with DNP3 over Ethernet, certainly, but that's just a TCP port or a UDP port tag in the system. You want to open that up somehow?
Yeah. GoToWebinar makes it fun to try to see what the actual questions are. Oh, here we go. We got a few. Yeah. Okay.
All right. So one IP network listener tag for each driver. Does it cover all drivers? You're going to need one per port number. With DNP3, that'll often be one for all, sitting on port 20,000.
And this is not the first time we've received this question from this user. Hi again. We still don't have a release date except for version 12, but it is very soon. I have a version 12 running on this computer. That's what we're looking at right now. So that's how far we are into the process. So it's right now I'm in a mad dash to update our marketing materials because it could happen tomorrow or in 2 weeks' time. Again, someone's going to come in and hit me with a shoe for answering that much.
Yes. So this DNP slave.xml configuration file for the MultiSmart, it comes from the configuration, and there's actually a ton of ways to get it. But the MultiSmart comes with a flash reader, and you can usually just pull it off the flash card. You can also telnet to the device and download it, and it is possible to download it using our DNP3 driver. That functionality is not automatically built into the product to VTScada, but it is something you can do if you're comfortable with the deeper corners of VTScada.
So your demo worked perfectly, nice job. But when things don't go so well, what debugging tools are there?
Sure. So with all of our drivers, let's just flip out to, here we are. Just flip out to our application here. So most of our drivers have sort of the same three things that they'll tell us. One of them is the value of the driver tag itself. So when we've got our driver tag, it's going to have a value. And that can be a good thing to draw on the screen where you've got the thing that you're looking at.
How to do that?
Sure, we can just grab it and draw it.
And then you'll see only the widgets that support that type.
Yeah, so a couple things here, and all of our drivers do this. All these indicators, they'll show green when it's good, they'll show red when it's bad. And then with the text, if you just drop a numeric value on the screen, decimal places don't generally make sense. But a value of 0 for any of our drivers means that the last thing it tried to do worked. Right? So if it tried to read or it tried to write, whatever it was, it worked. And if we go back to the MultiSmart page, this normal text actually means that it's 0. If there was an error, it would show it there. And again, with all of our drivers, we will have the comms and stats widgets for them. And these are unique to each individual driver. The stats will pop up and it will be information relevant to the driver. So this is what it looks like for the DNP3 driver. And it shows you a bunch of information here about what's going on. So the counts are, each time it tries to do something, that will go up. The timestamp, date stamp, when did it last communicate? And then there's information about the error. So you've got this error code 0, that's what it is right now. But then the error message, it's sort of helper code to say, okay, what are we actually talking about here? Well, there's no error. If you had an error, it would give you a code and it would tell you what the error is or what it means. And you can also see statistics about, where there might be problems. So for example, if we broke this on purpose and just went and tried to talk to something that's not there, we should see this fail at some point. By the way, the comms dialog, the one now on the right, shows us the raw data that's actually being sent back and forth, so you can see what's there. DNP3 is a binary protocol, so if you can read this, power to you, but I cannot. And of course, you can press F1 from wherever you are with these, and it'll tell you more about it. But what I want to show you here, and there's a reference inside. Again, we have this for all of our drivers, but there's a table. So if you do get an error code back from the driver, what you need to know is what the problem is. And so the error code that you'll see is listed in this table, and it will tell you what's going on. And they're actually defined, we define them more as hex, and they are sort of grouped by where it came from. So this 300 series, these are all things that kind of came from the RTU. So for example, we sent something down like turn on unsolicited, and the RTU sent back function code not implemented. That's very common, and usually not a big deal. It'll show it as an error, but it doesn't really matter. It just means you can't do unsolicited. The device doesn't support it. These 200 block ones are what you'll generally see when you're having connectivity problems. If you send a message and don't get a response back, it goes into this kind of lightweight data link cycle where it's trying to reestablish communications, and it's pretty light messages going back and forth, and you'll get one of these errors depending on the specific case that you're looking at. And then there's a few more up here that might happen when we actually try to take our turn with the port tag. If there's reasons we can't do that, and we can determine that, we'll get something like that. But these error messages are usually what you'll see. And so we should have one now. You'll notice that our values have all gone. We aren't talking anymore. It's telling us there's an error, and we can hop into our statistics dialog and see that sure enough, data link reset, no acknowledge. It's UDP, it's connectionless, so we don't really know when we try to connect that we can't connect. We just know that we didn't get an answer. So the driver went into that sort of, can I get back going again, data link cycle. Typically, as with all things communication-wise on TCP networks, if you can ping it, if this is the actual IP address we're looking at, if you can ping it, and then for TCP, if you can telnet to the port, you'll probably be able to establish communications with VTScada. And if you can't do those things, you really don't have a chance with VTScada, because it means that you cannot reach the device no matter what you are. And a final thing that I'll note, this debug log level here, we actually have, and I think it's described in the help file, but you can actually turn on diagnostics specifically for a DNP3 driver and send us a really detailed trace of that. That's special to the DNP3 driver. It kind of captures very low level stuff that's going on here. So the 0 means that it's not there. You can turn it on by typing in DBG and it will set a log level.
You have the statistics thing open there?
Yes, and I believe that's documented. That's how you know to do it.
Yeah, I was going to say, that's like magic.
It is magic. And then more sort of standard fare, the trace viewer application allows you to capture all of the incoming and outgoing messages for a particular device. So this is common to all drivers in VTScada. If you hop in here and follow that sequence I just did, you can pick the driver you want to see, and you'll get actual communications going there as they come in and out. Once again, it's DNP3, it's binary, it's going to be a little bit hard to read. But if you are having issues with your driver, you can grab that, put it together, and send it into our tech support guys, because Doug and Jen and everybody else who supports them are just fabulous at wading through minutia like that to figure out what's actually going on. I say that, these land on all of us sometimes.
Right. That's great. Any more questions? Or sorry, Doug, you got one?
Oh, let's.
So I open up the little arrow.
Thank you.
And then just drag that over here, maybe. Okay, I think they're coming in at the top.
Yes, I think that's our next one.
Is there much of a difference in the DNP3 implementation between Multitrode and Kingfisher RTUs?
I can't comment on that. I believe that there are public testing organizations that basically audit the DNP3 implementation of people's devices, and that's where I would refer you to, is to one of those third parties. But you can sort of get a really good sense of what's going on with Wireshark if you're comfortable with it. You can just throw that up, do a trace. The dissector was actually written by Graham, who's the lead developer who wrote our own DNP3 driver, so it's very good. But yeah, we do see certain devices and things. That one doesn't ring a bell, so I don't know.
So is there a mechanism for determining the last communication timestamp to a DNP3 device? Our users like to see a changing number letting them know that comms are happening.
Yeah, so all of our driver tags actually log a bunch of diagnostic variables. That's not it. So you can actually plot the driver if it's drawn somewhere. And so actually where we drew the last one, just the value on the screen, it would have also supported that. And so you can see there's a bunch of stuff here. And we'll just zoom in a little bit so you can actually see it. Zoom in a little further. So there's a variety of things being logged here. So the error value is that 0, it's now 516. And so you can kind of see here as you go through that these are changing. So you get the error value, the failed count, the failed retry count. So how many times has it failed, or how many times has it failed when it's been retrying as well. We maintain a running quality value, which is sort of a measure of how much success to failure we're looking at. So values of 1 mean perfect, and values of 0 mean terrible, and values in between, you know, not great, but up close to 1 is usually what you're looking for. And this is sort of the portion, the fraction of communication attempts that have succeeded. And so if we watch this one over time, it's actually going to go down because we're not communicating successfully right now. And we track the response time, success count, error count. But specifically to answer your question, it's the success count variable here. So this is maintained in the driver, and it's going to increase by 1 or however many came in every time a successful communication is made. So you can actually see that one popping up as time goes on. And there are some timestamps you could watch probably, but you probably want to reach into our tech support guys for that sort of question.
Great. One IP network listener tag for each driver, or does it cover all drivers?
Oh, I think we've already answered that question. They're going from the top.
I'll come back to that again later.
All right. So the polling queue and multiple drivers are integrity polled at once. It is based on who got there first. So even though they're all the same, it's going to look random when it starts, and then it's going to sort of line up afterwards. One thing to put in as a comment is that the polling queue is for the reads going out, so integrity polls and event polls and things like that. There's actually a separate queue maintained for write. So if you do try to do a write right in the middle of a whole bunch of reads queued up, it's going to get its turn very quickly so that it's responsive in how it performs. The poll driver does the same thing.
Great. I think you may have noticed flash up on the screen, we actually have a multi-drug person on the line whose email showed up on the screen, so saying, woo! Nice to see a lot of familiar faces or familiar names on the attendee list. So any other questions we need to answer?
I think we've got everything that's there. Of course, if anything comes to you afterwards, please send it in by email. We will see that it finds an answer, and or just send it into tech support, because that's what they do too.
Great, thanks, Paul. Really well done. Would you pull up the presentation again? Just show the last 2 slides.
Absolutely.
So we have.
There we are.
Boom. There we go.
There.
And so if you want to learn about all of these connectivity protocols, or any new feature coming out in version 12, or any new feature that has been in all along, the best way to do that is to come to our 3rd annual users conference down in Orlando, Florida, which will be happening this March. So you can go to our website and find out all about it. It's a great 3 days. We also put some training on the front end of it. So if you want to go from having never used it before to being an advanced user, you can do that through the course of the week. And I think early bird pricing, I think, is still in effect. Again, I'm going to get hit with a shoe if it's not. So we invite you to check that out. People have found it really rewarding. Also, there's lots of nice relaxation networking time. And we have one more as part of this series before we release the next series of 3 on connecting VTScada to Siemens devices. So that'll happen with Lawrence, our head of engineering, and that'll be next month. And I believe that's everything. Thanks, Paul. You really moved through that quickly and clearly.
Thank you very much. Thank you, everybody, for attending.
And like I said before, everyone will receive a link, even those who didn't show up will get a link to this recorded webinar. So thanks, everybody. See you next time.
Bye now.